2023 on velocity time graph. So the question says, the diagram above illustrates a velocity time graph. Determine the distance between x and y. So let's quickly do this. So this is a velocity time graph being drawn here, and we are asked to determine the distance between x and y. So basically what they are saying we should find is we should find the distance covered by the body at the point in which the velocity remained constant. On the vertical axis is represents velocity. The horizontal axis represents time, velocity time graph. And we know that between points, this origin that is 0 to point x represents what? Acceleration, when the body is accelerating. Then between x and y represent when the velocity remains constant. That's when the body is not accelerating again. Acceleration between x and y is 0. Then between y and this last point is deceleration. So we have to find the distance covered between this when the body wasn't accelerating. So accordingly, distance covered by a body under velocity time graph is usually represented by the area under the graph. So if we were asked to find the total distance covered by the body, that would be finding the area of this shape form here, which is a trapezium. That will represent the distance covered. But since they say we should find the distance covered by the body between point x and y, that means we are only going to find the area formed by point x and y. And if you check point x and y, you see what kind of shape have the 2 points formed. You see that they have formed a square shape, or if we don't call it a square shape, we may be wrong, we might still call it a rectangle. So area, that's area of a square, equals to what? Length times breadth. And the length in this point is the distance between x and y. And how do we do the distance? Okay, area, let's make it in a way that will be more understandable. So area of a square or rectangle is what? Length times breadth. Okay, and our length, L, in this case, which is represented by time, T, is equals to what? T2 minus T1. And we know that our T2 is this point 8 minus T1 minus 4. And our T1 is what? 4, which will give us what? 4. And then our breadth, which is represented by velocity. As you can see, the height distance from here to here on the velocity side is 40, which is v equals to what? 40. And of course, we know that velocity times time equals to what? Distance. So we are trying to find distance between x and y. So therefore, distance xy will be equals to what? Velocity times time. And our velocity is what? 40. And our time is what? 4. So 40 times 4, 16. So that is that, and our unit is what? Meter. So the answer to this question is what? 160 meters. So the distance between x and y is 160 meters. Thank you. This example question, WAEC 2022, is which of the illustrated graph above represents a body moving with uniform retardation? Retardation means deceleration or negative acceleration. So accordingly, when it has to do with velocity time graph, acceleration is a straight line graph is a direct straight line graph in which increase in v correspond with increase in t. So this B, option B here, represents acceleration. Option A here is not a velocity time graph. There is no part of uniform velocity time graph that have this kind of curve. So this one is an exponential function. We use it for transient analysis. So option C means a constant velocity, which represents zero acceleration. Option D represents deceleration, or we call it retardation. So the correct option is D. Thank you. Acceleration of a moving object can be determined from the A, slope of its distance time graph, B, area under its distance time graph, C, slope of its velocity time graph, D, area under its velocity time graph. So I'll quickly do a sketch before telling you. So now if you say distance times distance distance time graph. So if you say slope slope of any line in a distance time graph, slope means change in the vertical over change in the horizontal, which is d over t. So distance divided by time, what will that give you? It will give you what? Velocity. So slope of a distance time graph gives velocity, not acceleration. So if you now the next one is area under its distance time graph. So if you have an area here, area which is usually length times breadth, in which you have distance times time, what will that give you? No, it will give you something we are yet to know. So B is not the answer. So C, slope of velocity. So if we have velocity here and time, slope means what? Change in V over change in T. And velocity over time gives you what? Acceleration. So the answer is C. Slope. So the acceleration of a moving object can be determined from the what? Slope of its velocity time graph. If we say area under its velocity time graph, area under velocity time graph represents what? Total distance covered. So C is the answer. Thank you. 2019, 2011. This means the year 2019 was a repetition. This question was repeated in the year 2011. So instead of doing separate videos for them, I'll just loop them together. Okay. So the question is, the area under a velocity time graph represents, like the analysis I did on velocity time graph, area under a velocity time graph represents the distance, or you say total distance covered. If this is your graph of a velocity time graph, whatever shape it forms, the area there, you know this place is V, and your horizontal axis is T. So area, assuming it was a square shape that was formed, area would have been what? Length times breadth, which is velocity times time, and velocity times time means what? Distance. So area under a velocity time graph represents what? Total distance covered. Thank you. The slope of a straight line velocity time graph represents. Now, I wouldn't just pick out the answer for you. If this is your graph, velocity time graph, that means velocity on the vertical axis and time on the horizontal axis. And remember, when in math, coordinate geometry, where we learn slope, how to calculate slope. Slope is what? Change in v over change in t. So slope is what? Change in v over change in t. And change in v over change in t, what does it represent? It represents what? Acceleration. It represents acceleration. So the slope of a velocity time graph represents what? Uniform acceleration. Option A. Thank you. This example from WAEC past question 2006. It says the diagram above shows the speed time graph of a car. If the car covers a total distance of 600 meters in 25 seconds, calculate its maximum speed. So let's quickly do that. Now, let's write out the parameters we've been given out. We've been given total distance, d, or you say s, okay, d equals to 600 meters. And then we've been given time that it used to cover that, in which is also indicated on the graph, 25 seconds. 25 seconds. So what we're now asked to find is the maximum speed, or you can say velocity, maximum velocity. And on the graph, the maximum velocity has not been indicated. You can see the maximum velocity represented by this line here, and you see they didn't indicate there. And what should have been here should have represented our maximum speed. So we have to find v, the value that should be here. So let's quickly do that. So as usual, you recall that total distance is given by what? The area formed by the graph, and the area under the graph, and the shape here is trapezium. So total distance equals to what? Area of what? A trapezium. And you know that area of a trapezium is given by a half into a plus b times what? Height. However, our a will be the distance between, our a, if we level this point x and then this point y, our a means what? Distance from x to y. Then our b means distance from origin here to here, which is 25. So we can now write our a equals to, how do we get distance from x to y? Distance from x to y will be what? The label on the distance of y, which is t2 minus t1, which is t2 minus t1, and our t2 is 20 minus t1, which is 5 here, to give us what? 15. So our b is already what? 25. That's distance from 0 here to that. So having gotten that, let's proceed to find our v. Now, this h here is what? The velocity. The h here represents what? The velocity. That's height. When you talk about height of the trapezium from here to here, they are that height. So according to this graph, is represented by velocity. So it is that velocity that we want to find. So we rewrite our formula as B equals to what? Half into our A is 15 plus our B is 25 times the height, which is our velocity, or you say maximum speed we are looking for. So we plug in our parameters. So 600 equals to a half, 25 plus 15. This will be 5, that will be 30, that will be 40 times what? V. So you now have 600 equals to 2 will cancel 40, 20 times 600 equals to what? 20 V. 20 V. So we now make B the subject of the formula by dividing both sides by 20. It will cancel that, cancel 2 will cancel 60, 30 times. So our maximum speed equals to what? 30 meters per second. That's how to do that. Thank you. Velocity time graph. It says the diagram below represents a velocity time graph. Determine the distance covered in the first 20 seconds. Okay, let's do that. Now, we have to find the total distance covered in the first 20 seconds. That's the distance covered from 0 to 20 seconds of the motion. So, and as usual, we know that distance covered is always equals to what? Area under the graph. And then they said the first 20 seconds, that means we are not considering the total area of the graph. We are only going to consider the area and stop at the 20 seconds mark, which is here. So between 0 to 20 seconds, what kind of shape do you have here? Of course, it is a trapezium. Why do I call it a trapezium? It has two parallel sides, top here and below, and two unparallel sides also. So that's it. But if you don't want to see it as a trapezium, you can also see it as a right angle triangle here first, a triangle here, then second, a square here, in which you find the area of this triangle and add it with area of this square to still give you the same. But in order to save time of too many analysis, I will go with area of a trapezium. You can also do both triangle and square, you still get the same result. So let's proceed. So in this trapezium, from the short length side from here to here can be given as our A, can be given as what? 20 minus 10 to give us what? 10. And then our B, from here to 20 seconds mark, our B equals to what? 20. Then the height, or you say the velocity, the maximum velocity of our graph is 4. Is 4. So you recall that total distance equals to area of a trapezium, and area of a trapezium is what? A half into A plus B times the height, but the height in this case is the maximum velocity or maximum speed. So let's plug that in and see what our distance in 20 seconds will be. That will be 1/2, open bracket. Our A is 10 plus our B is 20. Our maximum speed or our height is 4. So when you do that, that will be 1/2. 10 plus that is 30. 10 plus 20 is 30. Then times 4 here. So 2 cancel itself 1. Cancel 4 2 times. 2 times 30 is 60. So the total distance covered in 20 seconds of the motion equals to 60 meters. Thank you. Welcome there. This is physics under uniform motion. Let's look at this question from WAEC 1996. Okay, the question goes, the diagram below illustrates the velocity time graph of the motion of a body. Calculate the total distance covered by the body. So this is the diagram they're talking about. This is the diagram that represents the motion, the uniform motion of a body. So we are to calculate the distance, the total distance covered by the body. So first, looking at this graph, what kind of graph is this? This is a graph of velocity against what? Time. Velocity time graph. And then you know that velocity equals to displacement or distance divided by time. So that distance or displacement can be written as velocity times what? Time. Velocity times time. So what does this mean? It means that take for instance, if you take the square portion of this graph here, the square portion, if you do length times breadth, your length times breadth will be velocity times time, which will give you distance. So what am I driving at? What I'm trying to say is that the distance covered by the body is represented by the area of the shape formed by the graph. So the area under this graph will give you the total distance covered by the body. So now here is the task. How do we determine the area of this shape? This shape is not a shape that is really known to us. But however, since it's not a shape that we really know, that we can say, okay, this is the area of this is how to calculate the area of this shape. What we'll now do is we will divide the shape or segment it into the shapes that we know. Before then, let me label the shape. Here is already 0. At this point here, that is 10. At this point here, that is 10. I will label it A. And then here, this point here, B. And here, C. Here, D. And then here, E. And here, F. So I'm done labeling my graph. So now I'm going to segment this graph, or should I say divide it into various shapes, and then find the sum of the area of each of the shape. So let's dive into action. So now, distance covered, total distance. Total distance equals to what? Area under the graph. Area under the graph. So now, how do we get this area? So the first shape you can see here, OABF. Do you see that shape? OABF. This is a trapezium. Trapezium is a shape that has two of its sides parallel. So you see OA is parallel to what? BF. So, why this side is not? So, this is a trapezium. OABF. So, equals to the distance now equals to area of what? Trapezium. Area of OABF plus the next area here. The next area here we see looks like a square. The next area here is BCEF. Area BCEF plus. And the last shape we have here is a triangle. So area of a triangle. So this is CDE. Area of what? CDEC. CDEC. So this is it. So yeah, there are three shapes in this one shape now. So we're going to find the area of each of these shapes. So the first one here is a trapezium, OABF. So let's get things done. Okay, let me take that up. So now our distance, let me represent it with letter D, or total distance, will be area of a trapezium. Area of a trapezium is a half of the base. Half of the base. So what is the base here? Okay, a half. Area of a trapezium is a half times the summation of the parallel sides. The parallel side here is OA and BF. OA and BF. So we open that up. OA plus what? BF. We close. Then times height. Times height. What is the height of this? These are the two parallel sides. OA and BF are the parallel sides of this trapezium. So the height will be, the distance on the t-axis. So the height will be from O to F. From O to F. So what is the distance from O to F? From O to F is 5. So that would represent our height, OF. Okay, let me just write OF here first. OF plus, here is area of a square there. Which square are we talking? Area of that, okay. Plus area of a square. Let me still repeat it. B, C, that will be BC times what? CE. That's how to get area of a square or a rectangle. BC times what? CD. That's length times breadth, or breadth times length. BC times CE. BC times what? CE. Plus area of a triangle is a half of the base. Okay, a half of the base. So which of these is the base? The base could either be CE or ED, or this place. So a half of CE times what? DE. Half of CE a half of CE times DE. Okay, so this is the formula for area of a triangle. The first one for area of a trapezium, area of a rectangle or square. So let's plug in our parameters. This is 1/2. You open OA. What value represents OA? The O OA, that's from this 0 point to this point, is 10. From 0 here to the point is 10. So OA is 10. OA is 10 plus BF. BF from here to here, if you can see, you trace it down, it is 20. From BF, that's from down here to that top, if you trace it down, it's what? The length of this height is what? Is 20. So we write there plus 20. And then OF, which is the height, OF, that's from here to here, from O to F, that's 5. That is 5. Okay, plus BC times CE. BC times CE, let's extract that. BC from here to here, you see from here to here, between here and here is 5 to 10. So the distance from here to here will be 10 minus 5, which will be 5. So distance from here to here is 5. From here to here is what? It's 10. But we are looking for from here to here. So it will be this 10 minus this side will give you from here to here. So 10 minus 5 is 5. And then from here to here is 20. So that will be 5 times 20. So here will be 5 times 20 plus I have CE times DE. Let's extract that. CE times DE. Our CE, that's from here to here, is 20. Our DE from here to here is 5. I hope you know how we got 5. 15 minus 10. We want distance from here to here, so it's 15 minus 10 will give you what? 5. While from here to here, C to E is what? 20. That's with respect to the V axis. So this will be 20 times 5. 20 times 5. So I have times 20 times 5. So let's do our calculation now. So this is 1 over 2. 20 plus that is 30 times 5 plus 25 times 20 is 100 plus these 2 here will cancel this 20 10 times. So 10 times 5 is 50. Times 5 is 50. So 2 will cancel itself, 1 cancel 30. 15 times 5 is 75 plus 100 plus 50. Are we there? Yes, we are. So if you finish that up, 50 plus 100 is 150 plus this, that will be 225. 225 meters. So the total distance covered by that body is what? 225 meters. So this is how to do this. You can repeat the video several times to understand it better. Thank you. 94, a velocity time graph as our example. So the question says, the diagram above represents the velocity time graph of a body in motion. The total distance covered by the body is 195 meters. Calculate the acceleration of the body in section OP of the graph. In section OP of the graph. So section OP, this is OP. So they say we should calculate the acceleration at this section. And of course, we know that this section of the graph, OP represents acceleration. Then PQ represents zero acceleration or constant velocity. Then Q to the N represents deceleration, that's negative acceleration. So we have to find the acceleration OP. And we know that the slope of this OP, the slope of this inclined side of the graph usually represents what? Acceleration. And you know that acceleration A is what? Change in velocity over change in time. And our vertical axis represents velocity, horizontal axis represents what? Time. So the acceleration of OP will be what? A will be equals to B2 minus B1 over T2 minus T1. However, we have a challenge here. The challenge here is that we don't know our V2. Our V1 is 0. Our V2, or we call it V here, we don't know what our V here. And if we don't know what V is here, we cannot calculate that acceleration. So the first thing we have to do is to find this V. And then they've given us the parameter that the total distance covered by the body equals to what? 195 meters. So from this data here, we're going to use it to find our velocity first, our maximum velocity. Then with the velocity, we can now use it to find what? Acceleration. So let's proceed. Now, you recall that total distance D equals to what? Area of the graph, area of the shape formed by the graph. And what kind of shape is this? A trapezium, which equals to area of a trapezium is a half of the parallels of the sum of the parallel side, half of PQ plus what? O, I don't know, whatever we call it. If you call this one OR, or you call this place R, thing like that, OR. Then times the height. Area of the trapezium is what? A half of the sum of parallel sides plus, times the height. But the height in this case is represented by V, velocity, times V. So if we substitute, our D, which is the total distance, is 195 equals to a half. Our PQ, that's PQ, the distance, the length of PQ will be what? 11 minus 6. And 11 minus 6 is what? 5 plus. And then OR, which is from 0 to this place, is 21. Okay. So we proceed. So our D, okay, our 195 will now be equals to 1 over 2. Sorry, we forgot to write our V times the height, which is V here. 5 plus 21 is 26. That will be times 26 times. So 2 will cancel itself 1. Cancel 26. How many times? 1 and 3. 13 times. So we have 195 equals to 13 V. So to make V the subject of the formula. So to make V the subject of formula, we divide both sides by 13. We divide both sides by 13. Will cancel 13. This will cancel this 15 times. So therefore, our velocity our maximum velocity equals to 15 meter per second. However, we were not asked to find the velocity, we were asked to find acceleration. To find acceleration of the point OP. So our acceleration now will be acceleration A, which is change in V over change in T. Our change in V is 15. Our maximum V is 15 minus 0, while that of our T is let's look at it again. Our T is 6 minus 0. 6 minus 0, while our V is what? 15 here, which is 15 now minus 0. It will be 6 minus 0, which equals to 15 over 6. So if you do that math there, this will be 2.5 meter per second square. The unit of acceleration is meter per second square. So the acceleration between point OP equals to what? 2.5 meter per second square. Thank you.